All right, so when we start graphing these, right now our amplitude is, our period is going to be over 2 pi. And when we set up our graph, we're going to put 4 little ticks. Now, when you graphed this on the project, you did 1/3 pi, pi over 4, pi over 6, and then you went to 90. All I want to know are the 90, the 180. So I want to know what happens at pi over 2, what happens at pi, what happens at 3 pi over 2, and what happens at 2 pi. And I'd like a positive rotation and a negative rotation. So this will be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So I'm going to do each of these, all right, differently. All right, we're going to just plug our values in because we should have these memorized now. And obviously this is 0. So when I do this first one, I'm going to use red. And we're going to see what these values of 3 and 1/3 are going to do. Okay? So we're going to plug in our radians. What is the sign of 0? 0. Sign of 0 is 0. What is the sign of pi over 2? So what is the sign of 90? Sign of 90? 1, isn't it? Of 90. That's pi over 2. I'm just using this first formula and I'm plugging in my radians, okay? Y'all with me? That is at pi over 2, I am at 1 unit high. Radians is like an XY graph, okay? But my X graph represents all the radians, and my Y graph represents the value of the equation when I plug my radian in. Okay? Y'all with me now? All right, so then we're going to go pi. What's the sign of pi? So what's the sign of 180? You have to know these to graph these, guys. 0. What is 3 pi over 2? So what's the sign of 270? Negative 1. 2 pi? Back up to 0. Okay, so let's go negative pi over 2. Isn't negative pi over 2 the same thing as 270? And so we know that the sign of 270 is negative 1, right? And then negative pi is the same thing as regular pi, and that's going to be 0, correct? And negative 3 pi over 2, remember going clockwise, that's the same thing as 90 degrees. And that's going to be 1, isn't it? So at negative, we're going up, and then we're going back down. So here is my sinusoid, or the graph. Put arrows at the end because they don't stop, they continue. That's what the graph of a sine curve looks like. Okay? Now I'm going to do the sine curve, but I'm going to do the next one, y equals 3 sine of x. And I'm going to plug those same radians in. That was y is equal to the sine of x. Okay? So when I do y equals 3 sine of x, let's think. At 0, what did you say the sign of 0 was? And what's 3 times 0? So it's not doing anything there. Pi over 2, that's 90. What's the sign of 90? 1 times 3 is? So I'm way up here. What did that 3 just do to that point? Did it shift it, or did it translated it? Okay. All right, so then at pi we get 0, and 3 times 0 is 0. And at 3 pi over 2 we get negative 1, but then we really have to get negative 3, right? And so we're at 0, and then you can kind of follow the pattern. From here we're going to go down, and then we're going to go to the 0, and then we're going to go up, and then we're going to the 0. So that 3, this is called the amplitude. How high and low am I going? 3 units up, 3 units down. My amplitude is 6 units because that is from height to lowest point, 3 units altogether. Does that make sense? And we've got arrows at the ends because they continue. All right, and then we're going to do the 1/3. Well, what do you think the 1/3 is going to do? It's going to compress it, right? So it's going to take that point and it's going to pull it down 1/3. And it's still going to be 0 at the 0 marks, isn't it? But what was supposed to be 1 will be 1/3. And what was -1 will be -1/3. And so that same shape is going to happen. It's just a lot less, it has a lot less height. So you're always going to give me 4 ticks because that's going to be it'll be a whole period, whole time around. Okay? Are we good? All right, so where is the amplitude located? What determines the amplitude? Where do you find it on your equation? It's the what? Where do you find the amplitude? What's going to determine your amplitude? The amplitude is how high I go or how low I go. The 3 or the 1/3, or so it's that coefficient, isn't it? It's the coefficient. So on the back of this paper that I gave you for you, so it's half. If you go back and look, it's half that distance. My whole distance is 6. So when you look at this formula, at the back of the sheet here, all right, take a look at it. What represents the amplitude? The B. So B, I want you to put amplitude down. You didn't get one? Oh, you do. Okay. Yeah. Sorry, Maria. Here you go. So B, so you've got this, you've got that the back with all the little squares, right? And for the B arrow, put amplitude. It talks about the height. Talks about the height. Let me see here. It's half the difference between the highest and the lowest. Half the distance. So the distance between the highest and the lowest is 6. So the 3 is what's going to be that number that's out in front. Okay? Are you with me? Okay. So let's go on to the cosine curve. So clearly we know that the amplitude is going to be that number out in front. Okay? So the cosine's general curve, we're going to assume that we're just doing 2 pi for our domain, or period. So this is going to be pi over 2, pi, 3 pi over 2, and 2 pi. And then I'll go in the other direction. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. If you're looking here, what do you think the highest I have to be able to mark up to? If I'm looking at those 3 curves, I got to be able to go 2 up and 2 below. So let's go ahead and make 2 ticks up and 2 ticks down, just so that we're ready for the entire graph. And we're just going to do the cosine. The cosine I'm going to use blue. And we're going to put in our quadrangle. So we're going to do pi over 2. What is the cos? Actually, we're going to start with pi, 0. What's the cosine of 0? What is the cosine of 0? 1, right? So it starts differently. Where the sine starts at 0, at the origin, the cosine starts up because the cosine of 0 is 1. But the cosine of 90 degrees, or pi over 2, is 0. And the cosine of pi is -1. But the pattern is the same. It starts at 0, goes up, goes to 0, goes down, goes to 0, goes up, goes to 0, goes down. So this next one we know is going to be at 0, and at 2 pi we're back at 1. And then negative 2 pi we are at 0 because that's 270. And here we're at -1, and here we're at 0, and here we're at 1. And so we continue that pattern. And that's the general cosine. So when you see that hump, you got to look where the hump is. If the hump is on the y-axis, you're dealing with the cosine curve. If the hump is off to the side of the y-axis, you're dealing with the sine curve. because it's going through the origin versus starting at 1 on the y-axis. Do you see that? Okay? All right, so then what's different about this next problem? There's this negative. So the question is, what do you think the negative sign is going to do? Well, it's got, right, because we talked about translations, didn't we? It affects the value of the y because it's going to be out in front. So whatever was initially positive is now going to be, and vice versa, but 0 will still be 0. So I know that at 0, the cosine of 0 should be 1, but the negative sign gives me negative 1. But if I follow that pattern, I know that at pi over 2, which is 90 degrees, the cosine is 0, and it still stays 0. Doesn't matter if I have a negative in there. At pi, the cosine of pi is negative 1, but the negative sign out in front makes it a positive sign. I'm just doing this problem right here. And then I'm going to go back to 0 and back down. Up to 0, up to 1, down to 0, to negative 1. And so this is the curve of a cosine that's been flipped because of the negative sign. Starts on the y-axis. Does it start above? It's positive. If it starts below, there's that negative sign. So you want to write on the back of your sheet that a positive b means you're starting above, and a negative b means you're going to start below. So what does the negative sign do? It flips the graph. On the back, yeah, like whatever we talked about, that b, put it in addition to that, it changes the direction. Okay? All right, so now here's what I'm going to do. I'm going to be comparing by adding and subtracting the 3. Now think about what this did with, like, when you added and subtracted things to your parabolas. It translates it. Now which way is it going to translate it? You think? Is it up and down, or is it left and right? Is it with the x or not with the x? It's not with the x. So if it's not with the x, what's it going to do? Up and down. X is left and right, isn't it? Oh, I knew. Yeah. You were saying some different what you meant? Okay. Okay, good. Well, I'm glad you knew, because I didn't know. All right, so that means on your flip sheet, what letter represents what we're always adding? C? B? I don't know what it is. What is it? It's the A. So they have it a little bit out in front, right? That A is out in front versus to the back. But that A is going to be, it's going to affect the Y value, moving it up or moving it down. It's going to translate your graph up so many units or down so many units. And it's moving that center line. It's moving your center line. Currently, our center line is at 0. But it's going to move that center line 2 units up or 3 units down. So we're going to use some dotted lines to determine where our center line is, okay? So our normal center line is at the origin, is at 0, okay? 1, 2, 3, 4, that's 2 pi and pi over 2. 1, 2, 3, 4, negative pi, excuse me, that should be pi. Negative pi, negative 2 pi. I just did every other. Okay. So on a normal sine curve at 0, what's the amplitude for all of these? What's the amplitude? Where do you find the amplitude? It's right in front. What number is right in front? 1. So from my center line, I'm going to go up or down 1 unit. But my center line is going to be changing because we are moving things up and down, right? So for this first one, 1 is my amplitude, which means I'm going to go up 1 and down 1. So here, oops, missed my point. Here is my graph of my sine. We are at 0. At pi over 2, we're at 1. At pi, we're at 0. 3 pi over 2, negative 1. 2 pi, 0. So I did every other, right? When you're doing these graphs, guys, you have to use graph paper. I do not want sketches on blank paper. You have to use graph paper. All right, so for the next one, this center line, which is at 0, is going to get bumped up 2 units. 2 units. So my center line is up here now. And from that center line, my amplitude is still going to be what? At 1. My amplitude from the center line that got shifted up 2 units is now going to be 1. So I need to give myself 1 extra tick. And we just want to remember that at the sine of 0, we're 0, right? But then we're going to add 2 units. Right? The sine of 0 is 0, and then we add 2 units, so we're at 2. At pi over 2, the sine is 1, but we're going to add 2 units, and so that means we're going up. So see, look at this. All we have to do above that center line after we get that first couple dots is follow the pattern around that new center line. Because next one over pi, where am I going to end up at? On the center line, above or below? On. And then over 3 pi over 2, which is right here, where am I going to land? By how many units? Because that's my amplitude. You following this pattern? And then here, I'm going to go back up. And then on the left side, if this was an up, then this one has to be down. And then this one has to be on or 0, and this one has to be, and this one has to be right. So you got to make sure that your pattern looks right. Okay? Above, through, below, through. Sometimes I get something that looks like this. They'll go woo woo and then woo woo. I'm like, yeah, no. Okay? So you got to keep track of that pattern. All right, the last one is going to be moving that down 3 units, our center line. So put that little dotted line so that you know what you're going up and down around. We're going to start at 0. We're going to go up 1, 0, down 1, 0. And here, down 1, 0, up 1, 0. So they can fall right on top of each other. They've just been shifted up or down depending on the units that we are adding or subtracting out to the side. No, it's all going to be all different problems. And each one is going to have its own graph. Okay, so what does the 2 and the 3 do? It shifts it up or down. It affects the y. It affects the center line. It moves it up and down. Okay, that's day 2. That's all we're doing right now. Okay? And you'll find your homework at the bottom of the notes. I think it'll say homework, or there should be like all the homework maybe in one section. Day 1, day 2. There's like 10 problems. You found it on Moodle? It's on a Word document? Yeah. You're just doing day 1. Right. I mean, you can do more, but